On August 17, 2009, in the heart of Siberia, a routine morning at one of the world's largest hydroelectric power plants turned into a scene of unimaginable chaos. The Sayano Shushenskaya Dam, a marvel of Soviet engineering standing tall on the Yenisei River, was about to experience a catastrophe that would send shockwaves through the global energy industry. This wasn't a natural disaster. It was a man-made failure of catastrophic proportions, and it would ultimately claim 75 lives. What went so terribly wrong inside this concrete giant? And what lessons can we learn from the tragedy that unfolded deep within its turbine hull? The Sayano Shushenskaya plant was a source of immense national pride for Russia, completed in 1985. It was the largest power plant in the country and the sixth largest hydroelectric plant in the world. Its massive arch-gravity dam held back an enormous reservoir, channeling the immense power of the Yenisei River through 10 powerful Francis turbines. Each of these turbines, a complex assembly of steel and precision engineering, weighed over 1,500 tons. For decades, they had spun reliably, generating clean energy for millions. But hidden beneath the surface, a fatal flaw was growing. The heart of the problem lay with Turbine Unit 2. In the months and even years leading up to the disaster, this specific turbine had been exhibiting worrying signs. Workers had reported excessive vibrations for a long time. It was a known issue, something that was monitored but never fully resolved. The vibrations were so severe that they would sometimes exceed the manufacturer's specified limits. Attempts to balance the turbine had been made, but the underlying cause was never properly addressed. The turbine was essentially a ticking time bomb, shaking itself apart with every rotation. On that fateful August morning, Unit 2 was operating under a fluctuating load as it was used to regulate the frequency of the electrical grid. This constant adjustment put additional stress on the already compromised machine. Just before 8:13 a.m. local time, something gave way. The bolts securing the massive turbine cover, each one a thick steel stud designed to withstand immense pressure, began to fail. A phenomenon known as metal fatigue, caused by the relentless long-term vibrations, had critically weakened them. One by one, they snapped. The immense upward pressure from the water flowing through the turbine no longer contained did the unthinkable. It launched the entire 1,500-tune turbine and generator assembly upward. The massive structure was ripped from its foundation and thrown into the air, tearing through the floor and roof of the enormous turbine hall. What followed was an instant of pure destruction. A torrent of water under colossal pressure erupted from the gaping hole where Turbine 2 once sat. The turbine hall, a space the size of a football field, began to flood at an astonishing rate. Water surged through the massive chamber, carrying with it debris, mangled steel, and electrical equipment. The lights went out, plunging the hall into darkness, broken only by the terrifying flashes of electrical short circuits. Workers who had been performing maintenance on other turbines were caught completely off guard. The sudden roar, the explosion, the immediate deluge of freezing river water, it was a nightmare realized. Some were swept away instantly by the force of the flood. Others were trapped by debris or electrocuted as live wires hit the rising water. The sheer volume of water was overwhelming, rose several meters in just minutes, turning the vast hall into a deadly, churning lake. The emergency systems that should have prevented such a disaster failed. The main water intake gates, designed to shut off the flow to the turbines in an emergency, did not close automatically. The power supply needed to operate them had been severed in the initial explosion. This meant the floodgates were literally open, and the Yenisei River was pouring unchecked into the power station. A desperate manual effort began. Workers had to climb to the top of the dam, a chaotic and dangerous journey in itself, to try and manually lower the 125-ton gates to stop the inflow. It took nearly an hour of frantic work to finally cut off the water supply. But by then, the damage was done, as the entire turbine hall was submerged. The immediate aftermath was a scene of devastation. Emergency crews arrived to find a building shattered and flooded, with a gaping hole in its roof. The search and rescue operation was perilous. Divers had to navigate a treacherous underwater environment filled with sharp metal, tangled cables, and unstable structures, all in near-zero visibility. They searched for survivors, but as the days went on, the mission tragically shifted to one of recovery. For weeks, they pulled bodies from the wreckage. In the end, the official death toll stood at 75. These were engineers, technicians, and maintenance workers, people who had gone to work that morning and never came home. The investigation that followed painted a damning picture. It wasn't a single error, but a cascade of failures. The primary cause was identified as the metal fatigue in the turbine cover bolts, a direct result of the long-term excessive vibrations that were known but not adequately addressed. The investigation report cited a culture of prioritizing power generation over safety maintenance. The pressure to keep the plant running and generating revenue had led to shortcuts and the postponement of critical repairs. Furthermore, the automatic safety systems were found to be inadequate. The failure of the intake gates to close automatically was a critical flaw in the plant's design and emergency protocols. There was no independent, fail-safe power source for these crucial gates. The Sayano Shushenskaya disaster served as a brutal wake-up call for the global hydropower industry. It highlighted the catastrophic potential of aging infrastructure when combined with a weak safety culture. The event prompted a worldwide review of safety standards at large dams and power plants. In Russia, it led to a complete overhaul of safety regulations and a massive investment in modernizing its energy infrastructure. The crippled power plant faced a long road to recovery. The cleanup was a monumental task, involving the removal of millions of gallons of water and tons of debris. The turbine hull had to be almost completely rebuilt. It took over 5 years and billions of dollars to restore the plant to its full operational capacity. New, more advanced turbines were installed, and safety systems were fundamentally redesigned to prevent a repeat of the 2009 tragedy. Today, the Sayano Shushenskaya Dam stands as a symbol of both incredible power and profound loss. It's a reminder that even the most impressive feats of engineering are vulnerable to human error and neglect. The 75 people who lost their lives are a permanent testament to the immense responsibility that comes with harnessing the power of nature. Their story underscores a vital lesson. Safety can never be a secondary concern. In the world of high-stakes engineering, vigilance and a commitment to maintenance are not just best practices, they are the guardians against catastrophe. Thanks for watching, and if you found this story important, consider subscribing for more deep dives into the events that shaped our world.